So if you've ever dipped your toes into Kubernetes, you've probably been hit with a wall of jargon, right? We're talking pods, services, deployments, clusters. It can seriously feel like you're learning some kind of alien technology. It's complex, it's confusing, and honestly, it can be pretty intimidating.
The whole thing just seems to work by some kind of digital sorcery. You throw some YAML at it, and boom. Suddenly your application is running, it's scaling, it's managed across a whole fleet of machines. But how? How does that actually happen? Is it really magic?
Well, here's the big secret. The one idea that, I promise, will change everything for you. What if all that complexity, all that crazy jargon, is just a fancy new wrapper on top of concepts that have been part of Linux for decades? That's what we're going to break down right now. Okay, so let's pull back the curtain. We are going to translate the language of Kubernetes and reveal the simple, powerful reality that's been hiding underneath it all this time. Okay, check this out. This is where it all clicks. All that intimidating jargon, let's translate it. When Kubernetes says container, what it really means is just an isolated Linux process. A pod, that's just a group of those processes that are meant to work together. And a cluster, well, that's just a bunch of Linux machines networked together. You see? Kubernetes didn't invent this stuff out of thin air, it just gave it a new and very powerful packaging. So to really get this, we've got to go back to basics. We need to look at the original building blocks. These are fundamental features baked right into the Linux kernel that make all of this possible in the first place. First up, namespaces. This is basically the magic ingredient for isolation. A namespace is a super cool kernel feature that carves up the system's resources, so one process, or a group of them, can have its own private view of things, completely separate from everyone else. This is the absolute foundation of separation. And here's a perfect way to picture it. Imagine every single process gets its own private room. Inside that room, it thinks it's the only thing in the entire world. It has its own private network, its own private file system. It can't see or mess with the processes that are in any of the other rooms. That, right there, is what a namespace does. Now, the second piece of the puzzle is something called cgroups, which stands for control groups. So if namespaces give a process its private room for isolation, cgroups are the rules for what that process is allowed to do inside its room. Exactly. The best way to think about cgroups is like a resource budget. They are the thing that actually enforces the requests and limits you're always setting in your Kubernetes files. So when you tell a container it can only use, say, half a CPU core and 512 megs of RAM, it's a Linux group that's behind the scenes, making sure it sticks to that budget. All right, so we've got our Lego pieces, right? We've got namespaces to build the walls for isolation, and we've got cgroups to set the rules and resource limits. Now, let's put them together and see how we actually build what we all call a container. And this is it. This is literally the recipe. You start with any old Linux process. Could be anything, like nginx, or even just sleep. Then, you wrap it up in a cozy blanket of namespaces to give it that private room. Next, you apply cgroups to set its budget. And finally, you give it its own little file system to look at. And that's it. You've just built a container, conceptually speaking. I want you to let that sink in for a second. A container isn't a mini virtual machine. It's not some kind of magical, mystical box. At the end of the day, it's just a totally normal Linux process that's been given a special, very constrained view of the system it's running on. That's all. And this same simple logic just keeps building on itself. We know a container is just an isolated process. Well, a pod? That's just a little group of processes that all agree to share certain things, like the same network namespace, so they can talk to each other easily. And a node in Kubernetes, that's just a Linux server, plain and simple. So a cluster is just a group of those servers working together. See, it's all just Linux, all the way down. Now, understanding this isn't just a fun little trivia fact, it's a superpower. I'm serious. It will fundamentally change how you think about, work with, and especially how you troubleshoot Kubernetes. Just look at this shift in your thinking. Before, you're wrestling with all these abstract ideas. Okay, I need to deploy this container image into a pod, which is inside a Kubernetes namespace, and that's on a node. It's a total mouthful. But after you get this, your goal becomes so much clearer. Okay, I need to run my app process, make sure it's isolated, give it some resource limits, and run it on a few of my servers. It stops being a jargon puzzle and becomes a straightforward engineering problem. And this is the practical payoff. This is the best part. When something breaks, and things will break, you no longer have to just throw your hands up and say, Kubernetes is broken. Instead,
you can start asking the right questions. What is the actual Linux process ID for my container? What namespaces is that process running in? And what are its cgroup limits? You can use standard, everyday Linux tools to figure out what's really going on under all those layers. And that's really the ultimate goal here, isn't it? To go from feeling like you're dealing with magic to feeling like you're dealing with engineering. Kubernetes is an absolutely incredible tool, don't get me wrong. It's a brilliant process manager for distributed systems. But you can't ever forget that underneath all of it, it's just Linux, doing what Linux has been doing for a very long time. And once you truly grasp that, the whole system becomes predictable, and you become a much, much more effective engineer.